Welcome to the Architecture Corner.
Great to be here.
Today we're diving into something really interesting. It's about software design, trying to get the best of two different worlds almost.
Yeah. You mean mixing functional ideas with the, let's say, more traditional ways?
Exactly. There's this pattern, drawing on some great insights from Mario Bittencourt, that helps blend the predictability of functional programming
Which is super clean.
with the fact that, well, real applications have to deal with messy, real-world stuff.
Right. Because, traditionally, especially in big systems, enterprise stuff, it's all been very object-oriented. Classes, objects holding state.
That's what most of us learned.
Yeah. But there's this other way, the functional approach, and it's really picking up steam. For good reasons, too.
So, okay, let's unpack that. What does functional programming, or FP, actually mean in practice? If it's gaining traction, what's the core idea?
Well, fundamentally, it's a shift. You stop thinking so much about objects changing over time, and you start thinking about applying and composing functions.
Functions, like just pieces of code.
Well, yes, but they're treated as first-class citizens. You can pass them around, return them from other functions. It gives you a lot of power.
Okay, functions are key. What makes them so special in this FP world? Are there specific principles?
Absolutely. Two ideas are really, really central. First, pure functions.
Pure functions.
Yeah, a pure function is like totally predictable. You give it the same input, you always get the same output back. Always.
Always, no exceptions.
Nope. And crucially, it doesn't change anything outside of itself. No side effects, nothing.
Ah, okay. So it just calculates something based on its input.
Exactly. Think of it almost like a lookup table. That predictability makes testing, well, way easier. Like imagine classifying a credit score. The score comes in, the classification goes out, nothing else is affected.
Got it. That makes sense for testing. What's the second core idea?
That would be immutability.
Immutability, so things don't change.
Right. In a purely functional style, when you need to represent a change in state, you don't modify the existing data.
You don't? Then how?
You create a new version of the data with the change applied. The original stays exactly as it was.
So you're always creating new things instead of editing old ones.
Pretty much, yeah. It avoids a whole class of bugs related to unexpected state changes.
Okay, pure functions, immutability. This sounds incredibly clean, almost too clean. Because, applications do things. They talk to databases, call APIs, update screens. That sounds like side effects to me.
You've hit the nail on the head. That's the big challenge.
Yeah.
The real world is side effects.
So how do you square that? How do you keep the pure core but still, do stuff?
And that brings us to the pattern. The functional core and imperative shell.
Functional core, imperative shell?
Okay. The idea is you structure your application very deliberately. You put all your pure business logic, all those pure functions and mutable data structures into the functional core.
Isolated.
Totally isolated. Predictable, testable, no side effects allowed inside. Then you wrap this core with what's called the imperative shell.
And the shell is the messy part.
Kind of, yeah. The shell is where you handle all the interactions with the outside world. Database calls, network requests, UI updates, logging, all that happens in the shell.
And there's a clear rule?
A very clear rule. The shell can call functions inside the core to get calculations done or figure out the next state.
Okay.
But the core never calls out to the shell. It doesn't even know the shell exists, really. It just takes data in and spits data out.
Huh. That sounds familiar, actually. It reminds me a bit of hexagonal architecture or ports and adapters.
Exactly. There's a very similar goal there.
Keeping the important business stuff protected from the implementation details and the outside world.
Precisely. It's about creating boundaries or protecting that core logic. And this functional approach fits really nicely with domain-driven design concepts, too.
Oh, really? How so? Like with value objects or entities?
Yeah, perfectly. Take value objects. They're supposed to be immutable anyway, right?
Yeah.
So defining them using pure functions that enforce rules, like maybe ensuring a flight origin is different from its destination, that's a natural fit.
Okay, makes sense for value objects. What about entities? They have identity, they change over time. That sounds stateful.
It does, but you can handle it functionally. Instead of having methods on an entity that mutate its internal state.
It's like entity.approve, changing a status field.
Right. Instead, you have a pure function. Maybe approve entity takes the current entity state and returns a brand new entity instance representing the approved state.
Ah, so you're using immutability again, even for things with a life cycle.
Exactly. Think of a fraud case entity. Functions like approve case or decline case wouldn't change the original case object. They'd return a new fraud case object reflecting that decision. It's still pure.
So the big takeaway seems to be you don't have to throw away functional programming just because your domain is complex or needs state. This pattern gives you a way
The practical way, yeah.
to leverage those FP benefits like clarity and testability right where it matters most in your core business rules without ignoring the messy reality of building software.
It really helps keep things clean and maintainable.
It's a neat way to structure things, a really powerful aha moment, I think.
And maybe a final thought for you to consider. How this pattern encourages you to shift your thinking. Less about mutating state,
Changing things in place.
and more about transforming data. Taking input data, applying pure functions, and producing new output data. It often leads to more robust, easier to reason about code.
Thinking in transformations. I like that. A great perspective to end on.
Glad we could chat about it.
Thanks for joining us. If you want to dig deeper, check out the description for more information on everything we discussed.
Definitely worth a look.
And hey, while you're there, why not subscribe? It's free. Find the Architecture Corner newsletter at architecturecorner.substack.com. See you next time.